Hello. Thanks everyone so much for joining us today for this talk on Google Cloud Security. My name is Sarah Fender, and I lead product management for a few of our Google Cloud Security services, including Security Command Center. And I'm joined today by Vandy, who leads a team of product managers that are focused on Security Command Center posture, governance, and compliance. So in this talk, we're going to discuss what we consider to be the 5 indispensable technologies that you need to use for securing your Google Cloud estate. We're going to, along the way, talk about the capabilities that Security Command Center offers in these various areas, and we'll highlight some of the latest releases and new innovations that we've delivered over the past several months, and even some that we've announced just this week at Next. So we'll try to keep things moving so we have a chance to take a few questions towards the end. So let's go ahead and jump in. So we'll start just a quick preview of what we're going to talk about today. Which are those 5 indispensable technologies we're going to cover? We're going to start by talking about technologies that help you to limit your exposure to risk. This is things like proper resource configuration, vulnerability management, permissions, and identities. Now, we're talking about dynamic cloud environments, so it's not uncommon for there to be a large number of posture and vulnerability findings in those environments. So we're going to move on to talk about how attack exposure can be used to assess risk and prioritize remediation of those issues. Finally, we're going to wrap things up with technologies that help you to detect attacks, targeting your cloud environments, helping you to stay ahead of the rapidly changing threat landscape. So I want to talk for just a moment about these common issues, top of mind concerns that we hear from customers just like you. First is just this essential question about what is running in your cloud environments, and are those environments vulnerable to attack? They seem like they would be relatively straightforward questions, but in the cloud, that's just not the case. This is an environment where resources are changing all the time. They're being spun up and spun down. The management of these cloud environments is often not centrally managed within an IT organization as it is in some on-prem environments. It's distributed to various workload owners that exist in various parts of the organization. There's this essential question about, am I under attack? And again, answering this question in the cloud is a bit challenging. There are new attack tactics, techniques, and in some cases, new objectives that attackers are going after. And finally, customers need to understand how to meet their compliance obligations. Many companies are just no longer willing to block their cloud adoption on compliance regulations, and they're tasking their cloud and their cloud security teams with finding a way to effectively monitor and report on the compliance of these cloud environments. Security Command Center is really designed to address these top-of-mind concerns for customers. It provides visibility into this ever-changing set of assets, continuously monitors for these assets for misconfigurations, identifies vulnerabilities, and assesses the risk exposure. It monitors for malicious activity and unauthorized access to detect active threats. And finally, it provides out-of-the-box compliance mapping and reporting to enable you to meet your compliance requirements. And it brings all of this together into one central tool that provides visibility across your entire GCP estate and throughout the security lifecycle. Now, all of these capabilities are powered by Google Insights, innovations, and expertise. Security Command Center leverages the best of Google threat intelligence for cloud security use cases, provides actionable, accurate, and timely detections of threats by leveraging Mandiant threat intelligence and uppercase. This unique set of knowledge that we have into attackers, threats, exploits, and activities. It has generative AI built in, using SecPalm AI and ML to analyze risk, to improve detections, to make operations more efficient. And it analyzes vast amounts of data to derive these meaningful insights into threats, risks, and surfaces the most critical issues. And it can help upskill novice security users and make security experts even more productive. So I'd like to pause for just a moment and take a quick poll of the audience. I'd like to see folks raise their hand if they have not heard about Google AI this week. No? No hands? I'm not at all surprised. We're pretty excited here at Google about the innovations that we're driving in generative AI. And personally, I'm just super excited about the potential that this has to help us solve some of our hardest security challenges. Finally, we have now Mandiant, which is part of Google, which brings us frontline expertise to help you mitigate threats and respond to an incident should one occur. And we can take the learnings from these engagements with customers to improve our security products and services, including Security Command Center. So now I'm going to hand it over to Vandy, who's going to kick off our top 5 list with a look at technologies that help you to start and stay secure.
Cool. Thanks, Sarah. So I'm really excited to start with our first set of technologies that is going to really help you and empower you to prevent misconfigurations of your resources and continuously detect those misconfigurations. So let's jump into it. One of the first things you need to be able to do to protect your resources from misconfigurations is to actually have visibility into your assets. And as Sarah talked about earlier, you can't secure what you can't see. And within Security Command Center, we have an amazing assets view that gives you near real-time visibility into your assets. This includes your resources like buckets and identities and whatnot, but also your policies. Within the asset view, you can look at the historical changes and act on any unauthorized changes by your teams. You're also able to see a consolidated view of findings and security findings for your assets and act on some of those findings for your critical assets here. So check it out within the Security Command Center assets view, and I'll dive into it in just a minute in our demos. So now, as those resources are getting configured and modified in your environment, we being the cloud provider, we know in real time whether or not they've been configured securely or insecurely. And as a result of this, we have hundreds of out-of-the-box detectors to catch any of those misconfigurations in real time. We've integrated deeply with a number of Google Cloud services, as you can see here: storage, networking, firewalls, identities, your compute instances, and we're able to detect them in real time. Another great thing is you've done all this hard work, you've configured your resources correctly, and we're continuously monitoring for them. But there's no point if you can't prove all this good work that you've been doing. So within Security Command Center, we have compliance reporting. This is a great capability for you to be able to detect and see how you've been performing against many of these popular benchmarks like PCI, ISO, CIS, NIST, and whatnot. And we're continuously improving our coverage and making this a go-to place for you to monitor how you're performing against them. And coming soon is CIS 2.0 benchmark, which I'm really excited to share with you all. All right, so we've talked a little bit about many of these out-of-the-box detections, but we've heard from customers like you many times that these detections are great, but my environment, I need a little bit more customization. So, you may want to have your KMS keys, for example, rotated every 30 days. And we have a great out-of-the-box detector to detect any key that's not been rotated within the 90 days. We also hear, so how do you do that? You can do that through customizations, and I'll touch on that in a minute. Another thing that we hear is you want more coverage across your resources. So now, with custom security health analytics detection modules, you will actually be able to detect misconfigurations across your assets in your inventory. You can configure these rules and detect these misconfigurations. Another great capability for you to be able to sort of detect and prevent misconfigurations is custom org policies. Security Command Center is deeply integrated with custom org policies. And if you know anything about org policies, it's a great way for you to sort of say, hey, here are the kinds of configurations that are allowed across my resources. And when they drift away from that, Security Command Center detects them in real time. So great way for you to start secure and stay secure. All right, I'm going to jump into a demo to talk through some of these and show you some of these capabilities. So here we are at the Security Command Center. You can find that within the security menu item. So here we are. We'll talk through all of these sections, but I want to jump into one specific finding here within the vulnerabilities section. Here, I'm seeing a finding. This is the compute secure boot disabled. And having secure boot enabled, as you know, protects you against rootkits and bootkits, and this is really important. I see that here under the resource display name, instance 1 is actually the one that's misconfigured and doesn't have this enabled. So I'm going to go to this assets view that I talked about to learn a little bit more about instance 1 and see what information I can get there. So navigating to the assets view, here I'm able to learn a little bit more about the instance. I can see the project it belongs to, the resource type, where it was created, what the state is, when it was created, including other metadata like the tags and the labels and the network information here. Clicking into the details view, I get additional information about this particular compute instance that doesn't have secure boot enabled. And looking at it here, it looks like there are 6 security findings. We'll touch on that in a second. That worries me. But I also get to see some of the other information, like the IPs and whatnot. So looking into the findings, really amazing. We've consolidated a lot of the security findings related to this particular compute instance here. You can see the change history and the full metadata. So let's verify that compute boot is indeed disabled here. All right, I have the confirmation that it's false. Now, I only saw one finding, but there could be a case where maybe other instances got exceptions from resource owners and security admins. So I'd like to actually go to the asset query to just ensure that which are the other compute instances that don't have secure boot enabled. Asset query, as you can see here, we have a number of templated queries for you. These are queries customers are running in and day out, and all you got to do is apply this query. Things around, hey, show me where these VMs have been created in a specific location. Show me who has access to a specific resource. But let's run this query here to figure out the other compute instances that don't have secure boot enabled. Right off the bat, the asset query gives me this result. Oh my, I'm seeing a long list of compute instances here. This is something, it looks like I have close to about 50 of them here. What I can do here is actually go ahead and export them, work with my developments to see which one warranted actually an exception, and fix some of the misconfigurations here. So it's a great way for you to use the asset view as well as the asset query. Now, let's dive into that security, in Security Command Center. Let's dive into custom security health analytics here. So as I talked about, we have this great out-of-the-box detector, and you can see that it's mapped to many compliance benchmark standards. Here, the requirement is that we're going to detect any encryption key that's not been rotated within the 90-day period. But what if you want to do it within the 30-day period? You want to ensure all of your teams are rotating keys under the 30-day period. You can do so within Security Health Analytics. Head over to Manage Settings under Security Health Analytics. Go over to Modules, and let's create a module to detect exactly this. So here I'm going to populate it. We're going to call this KMS key rotated within 30 days. The specific resource that I'm going to select here is the crypto key. Great. And using common expression language, you can really define simple detection logic. So here, we're going to say we want the key rotated within the 30-day period, which translates to about 720 hours. And let's go ahead and hit Next to define additional details. You can also specify the severity for your custom modules here and define exactly what it is that this detection is doing and provide comprehensive next steps on how to actually fix this misconfiguration should your team encounter this finding. So let's go ahead and create this module. All right, so it looks like it was successfully created. And as you can see here, this is the module, and it is enabled. So I've generated some findings for us. Take a look at this. The KMS key rotated. It's a medium severity, and let's dig into it. some Do It AI magic here in the AI-generated summary, and it's telling you, hey, if someone gets access to this key that has not been rotated, they could actually encrypt, they could actually have access to your data. This is really problematic. You get some really good information here from the AI-generated summary, including some security contacts that your team can go ahead and reach out to. You can look at the description that we specified, as well as the next steps for them to be able to go ahead and fix this. So it's a great way for you to configure misconfiguration detectors across your assets in your asset inventory. Now that we've talked a little bit about the custom detections, the out-of-the-box detections, you want to be able to prove all of the good work you've been doing. So heading over to the compliance menu here within the Security Command Center, as you can see here, we have reports based on a number of compliance benchmark standards, CIS, PCI, NIST, ISO. You can look to see how your environment is performing against many of these. Let's click into one of them, the PCI DSS here. And within each of these reports, we're providing you details on the modules and the detectors that actually are backed by that back up these benchmarks. You're able to see the exact category. You're able to find out the recommendations on how to fix them, as well as the active findings and the standards that all of these modules map to. Really great way for you to see how you're doing and export them to work with your teams, share them with your auditors and your executives based on all the work you've been doing. Great. So we talked a little bit about the first set of technologies, which is around misconfigurations. The next set of things I want to talk about, the second one is around software vulnerabilities. Managing risk is about managing your misconfiguration and your vulnerabilities. So I'm excited to share Web Security Scanner. This is the same exact technology that Google uses to protect its web applications. If you've built applications on top of Google Compute Engine or Kubernetes Engine or App Engine, we actually detect for a lot of those software vulnerabilities, things like SQL injection, weak passwords, cross-site scripting, right? Publicly accessible Git repositories. These are the kinds of vulnerabilities that we are regularly detecting even for Google and other customers as well. Many of these detections are mapped to the OWASP top 10 specifications. So really great way for you to protect your web applications against some of the software vulnerabilities. I'm also very, very excited to share that we recently launched the Integrated Vulnerability Scanner. This is an agentless vulnerability scanner that is powered by Tenable. And it produces close to about 80,000, it can detect over 80,000 findings and software vulnerabilities related to your OS, network, and application-related CVEs. And it does so in two ways. It does it by, one, doing an authenticated software scanning, targeting the VM's operating system, as well as the software applications that are running on it. And it provides additional information, like the network port bindings, things like the assessment, what security patches were applied to the operating system. And when it cannot authenticate, it actually does an anonymous network scanning of the VM's network interfaces. And we'll dive into a demo of these capabilities. So starting with the Web Security Scanner, you can actually filter for just those findings for your application under the source display name Web Security Scanner here. And as you can see, there are a number of software vulnerabilities that the scanner has detected here. A ton of cross-site scripting, some outdated libraries. Let's jump into one of the high ones, this cross-site scripting here. Again, AI-generated summary powered by Do It AI doing some magic here to get us some good summarization based on the content here. Here it's telling me, actually, we found a bug that's through the JavaScript callback. It's a high severity, it was recently created, and I get additional information about the application and where the resources live here. I also get to see additional information on the OWASP standards that this is related to. Let's take a look at another one. This is another bug that was detected through the vulnerability in the AngularJS module. And you can see additional information here around the specifications of the OWASP standard that it's violating. Great. So this is some of the ways you can use Web Security Scanner. Now, talking about the vulnerability scanner powered by Tenable, you can look for that under the software vulnerability module. Looking at it here, we find that there's one critical finding. So let's dive deep into it. So here, the SSH server is configured to support cipher chain blocking, cipher block chaining, and this is a big problem for us, so let's take a look. I also get to see that CVE ID that I talked about, and if you see here, you can actually find other security findings as well that have the CVE ID, so you can sort of focus on them holistically. Great, and you can look at the next steps here to work with your teams to remediate this software vulnerability. So we've talked about misconfigurations, software vulnerabilities, and the next thing I want to talk about is identities. One of the things when it comes to protecting your cloud, we know that it really starts with having a strong identity protection program and strong entitlements that are bound by least privilege. So when we think of this, right, Gartner has found that more than 95% of the accounts actually use less than 3% of the entitlements that they are granted. Think about this for a second. This is a huge attack surface, and this is because of a lot of misconfigurations in the policies that we give identities. And it's really, really hard to get this right in the cloud. You actually don't know how well you've configured it. It's, you're not sure what is the effective access. All of these things are problematic and make it very vulnerable for the identities and the access that they have. So with regards to misconfigurations and identity-related access drifts, we have a number of detections, out-of-the-box detections within Cloud Security Command Center. Things related to toxic combinations, when there's no separation of duties, right? We have a number of detections on that. We also have a number of detections for permissive grants. You've given some of these service accounts a lot of admin privileges. We also newly have IAM Recommender integrated into Security Command Center, and I'll demo that in just a second. And we finally also are able to detect public access to your resources. So if someone in your environment has an open group that gives access to GCP resources, we detect that in real time. And we're able to tell you this is really hard to do because, as you know, groups have tons of nested groups in there, but we're able to detect any public access within those groups in real time. We're also doing a lot with anomalous behaviors through our threat detection program here. With threats, we have a number of threats that we detect related to users and service accounts. And because we're the cloud provider, we're deeply integrated with a lot of these services to be able to detect anomalous behavior. When a dormant service account becomes suddenly active, these are things that we're able to detect and alert you right away. And this is really one of the ways we differentiate against with our threat protection program. Okay. So let's dive into this demo here. As you can see within Security Command Center, we have a number of detections that I just showed you. The admin service account, overprivileged accounts, too many KMS users when you should only be having 3 that have access to that key. Open group IAMs that makes it easy for anyone from outside your organization to have access. But let's focus on the IAM Recommender one. This is the overprivileged service account user. I see that there's quite a few of them, but I'm going to focus on the ETD E2E project here. It worries me because that's a production project. Looking at it here, I'm able to see that there's a recommendation for a service account. It looks like this service account can do 11 impersonations of other service accounts. That worries me. This is a really large blast radius here. And I see that there's a recommendation to remove some excess permissions here. So clicking into it, I love it. The recommender is telling me that I'm able to replace the editor role that has about 7,000 permissions with this other role that has about 50. It also tells you exactly the permissions that were used and all of the excess permissions that are safe to remove. And with the new role, it'll show me exactly that we're keeping the permissions that are used. And the things that you see in red here, these are all the things that are safe to remove as well with this new role. Now, something catches my eye here. If you look at this blue highlight here, this is the ML-generated inferred permissions. What it does here for you is that even though the user hasn't used this permission, we know that they'll need it at some point. And this makes it really safe for you to hit apply and remove all of those excess permissions. We have customers automating this at scale, removing thousands and thousands of permissions, excess permissions on a daily basis. So I highly encourage you to try this out. All right, and with that, I'll hand it over back to Sarah.
Thanks, Vandy. Attack exposure, as I mentioned earlier, is a really essential tool to understanding your most pressing security issues and prioritizing remediation. Attack exposure is powered by attack path simulations, which are used in Security Command Center to evaluate security posture findings and quantify risk. Now, we just launched this new capability over the summer, and already we're seeing that it's delivering strong benefits for customers. So let's talk for just a moment about this, the need. Why do we need this understanding of the attack exposure for various findings? First, for a variety of reasons, I mentioned some of these earlier, it's not uncommon for customers to have a large number of posture and vulnerability issues in this dynamic, ever-changing cloud environment. And so they really need to understand which of these are most essential for them to address first. Second, a high severity finding, a highly critical issue may be discovered on an asset that's really embedded deep within a workload. And so it may be that an attacker really can't access that particular resource, or it's very hard for an attacker to access that resource. So even though the finding is a high severity, the risk is not high. The risk, in fact, can be quite low. Third, often the greatest risk is posed by the combination of findings across multiple resources. And so you need the ability to connect the dots between those. Finally, not all resources pose the same level of risk to an organization. A database containing sensitive financial data, for example, is going to be a higher target of an attack, and the impact of a breach of that data is going to have more significant impacts and be more costly for the organization. So Security Command Center can identify the findings and the combinations of findings that pose the most risk to an organization's highest value assets. And it quantifies that by generating an exposure score. So let's talk a little bit about how it works. So the first step here is in the model creation. So we generate a big graph model of your Google Cloud environments, understanding the resources, the connections between these resources, identity and access policies, and more. So we build out this large model of your environment. And then the attack path simulations are conducted on that model, where a virtual attacker attempts kind of everything and anything, lots of permutations to try to gain access to these valued resources. Now, because the simulations are actually run on the model, there's no impact on your live environment. And the simulations include both what is 100% known about the environment, but also known unknowns, things like credential compromise and phishing. Now, you don't need to create complex queries to yourself kind of discover the risk that's posed. It's all fully automated. And because it's built into your environment, there's no agents to deploy, no snapshots that are sent to external systems for analysis. Now, the resulting insights of this are, answers to really vital questions, things like how exposed are your valued resources, what are the paths that pose the greatest risk, and which findings should you prioritize remediation of. So the resulting attack exposure score is that kind of primary mechanism that you'll use to prioritize findings. So you'll see that an attack exposure score is present on the most common misconfigurations and vulnerabilities. And you can sort this list based on that score and start at those issues that have the highest score. Now, that score is derived using an algorithm, and a variety of different factors are taken into account there. This includes things like the number and the value of the resources that are exposed. And now you have some control. You have control over the resource value definition for those assets in your environment. So you can define resource value high, medium, or low based on a variety of different parameters. Perhaps resources in a particular project or folder present a higher level of risk to the organization, therefore a higher value, asset value. It could be resource type, particular types of resources you consider to be higher value, or even your own custom labels and tags can be used. So the possible paths an attacker could take on a given resource, the probability that an attacker in these various simulations will successfully reach the destination of that high-value resource, the impact of a particular finding, and how it specifically contributes to the overall exposure. All of these are taken into account in calculating this attack exposure score. And finally, the most likely path is presented to you in an easy to use graphical experience. So you can actually walk the steps that an attacker would take in this particular path to gain access to your valued resource, clicking on various nodes to gain additional information about the resource and the findings that are related to that resource. This is an incredibly powerful visual tool, and we've heard from customers some stories recently about how they've leveraged this to encourage resource owners to resolve open security misconfigurations and vulnerabilities. The ability to actually step through and see step by step what an attacker can do to gain access to your resources, it's pretty compelling, hard to ignore, and can be a big motivator for folks to fix the issues that exist there. Andy?
Okay, so let's do a demo here of the attack path simulation. So I see here, as Sarah pointed out, you can use the score to actually prioritize the finding that you're going to focus on. I'm going to focus on the open SSH one. It's one of the higher scored ones. It shows me that the score is 24, and oh boy, it's associated with 4 high-value resources here, which once again you can specify and configure using tags, labels, and just selecting the exact resource that you value. So let's collapse this, and let's dig into this graph a little bit here. Zooming in, let's take a look. So this attacker coming in from the internet, right? I see that there are 4 things that they can do to get access to instance 1. Number 1, it looks like clicking into this with the SSH key, let's expand it, so they can steal the credentials of this SSH key, right? And then sort of take advantage of the vulnerabilities in the firewalls here. So that red thing that you see tells you exactly what the vulnerabilities are. So that one is an open firewall misconfiguration. This one looks like it has an open HTTP port. This is an open SSH port. So as an attacker, I can take this, use those firewall gaps, and get access to instance 1, which is a high-value resource. And oh boy, it looks like that one has a public IP address as well, and it has a service account that has an overprivileged service account user role. So I can take all of those permissions and then access the compute instance OS login. All right, so from there, let's see what happens. I'm able to make my way into instance 2 now, another high-value resource. And let's take a look at the service account attached to it. It has admin privileges and a service account user privilege as well that's over-permissive. Again, using these firewalls, it can get access to the compute instance OS admin login, and it makes its way, the attacker can make their way to instance 4, which is, again, a high-value asset in your environment. So this is a great way for you to sort of traverse the entire graph to understand the attack path an adversary can take.
Okay, we are near the end now. Our 5th indispensable technology is actually a set of both capabilities and intelligence that combine to help you detect threats. So detecting threats targeting your cloud environments is different. There are new planes of attack and new opportunities for instrumentation. In recognition of these unique threats facing cloud environments, MITRE released an update to their attack framework for enterprise that's really tailored at those unique tactics that are seen in attacks that target cloud resources. Now, Google, unlike many standalone security vendors, has really deep expertise in defending cloud environments and detecting cloud threats. And it layers that with unmatched threat intelligence. Now, aligned to the MITRE cloud attack framework, Security Command Center offers detections that span the MITRE kill chain and address the most common tactics. Now, this includes detecting initial access through brute force attacks, malware and crypto mining exploitation, persistence through anomalous IAM grants and privilege escalation, evasion techniques to anonymize access, credential access, and finally exfiltration of cloud services such as BigQuery and Cloud SQL. Threat detection in the cloud really requires this focus on both the platform and the workload. Now, at the platform level, this includes analyzing events in near real time to understand what changes are being made to your environments, who is making those changes, what are the implications of those changes. And this requires collection and analysis of identity, API, managed services, and network data. Now, at the network layer, this includes analyzing the software running on compute and Kubernetes instances, sometimes getting deep into the kernel layer. Security Command Center offers detection modules at each of these different layers, with special emphasis on detecting identity compromise, identity-related threats. Vandy shared a lot more with us earlier about the investments that we're making there and the capabilities that we have, as well as protecting compute and Kubernetes workloads at runtime. Now, at Google, we have unique access to telemetry from Google Cloud Services and cloud logging, and we can gain deep insights into compute and containers without requiring customers to install and manage agents. We can analyze this massive volume of data, again, in near real time, layering on mandiant threat intelligence and a variety of advanced analytics capabilities, things like UEBA, to help detect threats. And we're now enabling teams to extend our out-of-the-box and managed detections with their own private threat intelligence. They can create their own real-time detections using their own known bad IP addresses or malicious domains, or to identify activity related to break glass admin accounts. And finally, we're continuously innovating and delivering new detections to customers as we create new detection logic, as new threats emerge. Some recent additions include extending our agentless kernel integrity detections, expanding our crypto mining detections for GCE and GKE, and many of the identity-related detections that Vandy spoke about earlier, and much more. Again, this is a continuous process where we build, release, tune, and refine detections on an ongoing basis. Vandy?
Okay. So let's talk about a couple of the threads here. I'm going to start with the malicious script executed. What you're seeing here is an ML classification of a bash script that was executed in a container. Now, when it comes to protecting Kubernetes, you have to do it in a Kubernetes native way. And when it comes to defending, you actually have to understand what your attackers are doing. So when we started investing in Kubernetes threat detection, one of the first things that we did is we deployed hundreds of pieces of vulnerable software against the internet, and we monitored what are adversaries doing with that software, vulnerable software, in a Kubernetes environment. Now, what we learned is in 90% of those cases, somewhere in their kill chain, they actually executed a bash script. So what we did here at Google is we took some of those bash scripts, right, and we used natural language processing to actually teach our ML models to understand bash. Now, once we did that, the next thing was to train it to understand and differentiate between good and bad. And we did the good by just getting some benign scripts from the GitHub repositories. And the malicious ones we actually got from a source that we're contractually prohibited from mentioning. Okay, so now we've trained our models, we fine-tuned it, and we put it into production. And as you can see here, we show you the exact bash script hey, this was the bash script that was going ahead and getting executed, and this is something you can actually further dive deep into and sort of look into to see what it is that's going on here. And there you go. This is the exact script. It's a really cool way that we actually use ML to sort of detect your threats in your Kubernetes environment. Now let's go into another one that's also very interesting, and this is a crypto mining detection. Now, 86% of the compromises involve some amount of crypto mining, right? And when you think about an attacker getting into your compute environment, one of the top use cases is actually crypto mining. So we, being agentless here and doing this detection, we've deeply integrated into Google services. So this makes it really hard for the attacker to actually observe or evade any of this. So looking at this here, we're not just, understanding the contents of your memory, and great AI summary here telling you exactly what we've detected here for you. But we've not just gone ahead and scanned the contents of your memory using the Yara rules that you see here but we actually understood the kernel symbols, and we processed that hit, and we worked backwards, and we saw this. We said, hey, here's the exact process name, here are the arguments with which it started, and take a look. Here's the exact program binary that we think your team should look into, because this is the malicious code that's actually running.
So as Vandy mentioned, crypto mining attacks are really pervasive in the cloud. This is not a GCP-centric issue. For sure, this is widely seen across all of the cloud platforms. We are so confident, though, about our ability to detect these attacks quickly that we recently launched a new crypto mining protection program. So how this works, customers simply deploy Security Command Center Premium for their entire organization. They verify that it's configured according to best practices and that they have the appropriate security controls in place. And then if Google Cloud fails to detect a crypto mining attack, the customer can request up to $1 million in credits for any excess compute charges that were related to the attack. Okay, so this concludes our list of the 5 indispensable technologies related to posture, vulnerability management, attacks, and threats. But wait, there is one more. I have a bonus technology for you that I want to cover briefly. In order to realize the full value of Security Command Center, you must operationalize use of both the posture and threat findings. And for many customers, this involves integrating these findings into other systems. So Security Command Center offers seamless integration with our own Chronicle SIEM solution, and with this integration, you can easily pivot from findings details inside of Security Command Center into curated alert view inside of Chronicle. And from there, you can leverage additional data and workflows to investigate and remediate a threat detected by Security Command Center. In addition, Security Command Center includes many out-of-the-box integrations with leading ITSM, SIEM, and SOAR vendors. One of the most notable of those is our integration with ServiceNow, which includes support for multiple orgs, findings, dashboards, workflows, and much more. We also offer a pub-sub model, which enables you to integrate findings with virtually any third-party system, and you can also export to BigQuery. We have a lot of customers that do that to build out their own dashboards and custom reporting. Okay, so that concludes our 5 + 1, 6 top technologies. If you're interested in learning more, we're taking the show on the road, so to speak, so I encourage you to join one of the half-day cloud security workshops that are coming to a city near you. Cloud security experts are going to be there doing product demonstrations, technical deep dives, and roadmap discussions. It's a great opportunity to learn more, so you can scan the QR code, you can go to the Security Command Center website, or talk to your Google Cloud sales representative, and they can connect you with the event schedule. You can also continue your journey of learning by checking out the other related sessions at Next this week. So a couple of these have already happened, but they'll be available on demand. So certainly encourage you to check those out. A couple of great customers showcases here where you can hear directly from customers about their experiences using Security Command Center. I know sometimes that's incredibly valuable not to hear from the product team, but to hear from your peers and understand how they're leveraging the solution. So encourage you to check that out. And final slide is, to wrap us up, is we'd love to get your feedback. We're here to help inform and educate you, and so we want to make sure you're getting value out of these sessions. So please take a moment to give us some feedback and let us know how we can improve. So we had hoped to save time for a few questions, but we have hit the exactly 45-minute mark. So we won't be able to take those in the session live, but we'll be available after. Grab Vandy or I, and there's some other folks from the Security Command Center team here as well, and we'll be happy to answer any questions that you have. Thank you so much for joining.
Thank you.